That was weird. We're back, Jenny. My microphone works. Yay. It'll get better this week, I can tell. I got a feeling. If it starts here, it's gonna go up. I mean, I guess it could get worse. This is the worst thing all week. This is not bad. Okay, videos. Yeah, give me a minute. I gotta go back and load the YouTube live, the record thing back together. Is public. It'd be awesome if I got paid paid from YouTube. Doing that stuff. Okay, 7 weeks. The videos are too damn long though, or too long to do that. So college algebra. Right, no one wants to sit through an hour and a half lecture on section 2.6 in college algebra. Okay. Well, let me spotlight me. Wait, hold on. No, wait. There we go. Okay. We are where we stopped off. I know if you're watching that first video and then you're like, what happened? Or whatever. We had tech issues. We're back. Yeah. Okay. So any other questions about 2.3 and 2.4? I don't mind going over those. That's not a big deal.
39 to 48. I didn't really get there.
Oh, yeah. Yeah. Okay. So it says next one's 39 through 48. This is on page 255. Give the slope and y-intercept of each line whose equation is given. It's just writing it in function notation. So if we've got like f of x, this is number 44. 3/4 x minus 3. Remember, f of x is just a fancy way to say y. So therefore the slope, this is the slope, right? And then this is the y-intercept, 0, -3. That's it. Yeah, not a big deal. But it's the reason they put that in that section is because we're talking about functions. This class is really kind of centric around functions. So that's why. They just want to get you used to the whole function notation of the linear equation. 2.4? Did you get 2.4?
There was a couple things from grade change, but I can't really remember.
That's fine. Well, if you think of them, just let me know. And I don't mind, guys. I don't mind. And Caleb's in here. He's asking questions. I don't mind going over anything. If you wind up being 2 or 3 sections behind, and if you want to send me an email too, I don't mind going over. I might tell you, hey, I'm going to go over in the lecture, but just email me. That's the best way to get that ball rolling. Now, Janie or Amanda, did you guys have questions from 2.5? I'm getting a no from Janie.
No.
Okay. Then let's go on to 2.6. I'm going to tell you 2.6 is one of my favorite lectures because I get to do goofy examples. But the beginning of 2.6, we've already done actually. It was on the last test. It was the domain. And I'm only going to do one type of domain question just to review because we're going to see it in a few more sections. So the very beginning of 2.6 starts with a domain, which we went over when we went over 2.2. And I mixed in 2.6 and 2.2 because domain of a function equation, it should be a 2.2 subject, honestly. But let's look at this. If I had f of x equals, let's say 3 over x minus 4. Remember, if I ask you the domain of this, I need your brain to automatically see the x in the denominator and say, you know what, x minus 4 cannot be 0, right? Add the 4. Do you guys remember this? Hopefully this is jogging some memories from last week. And then if x can't be 4, we have to use interval notation. So negative infinity to 4 union 4 to infinity. This would be the domain. It might pop back up on the test as almost like a review, like, hey, don't forget these. But really, today I'm not going to focus on this part. I'm going to focus on actually the combinations and then eventually compositions. Hopefully we'll have time to get to compositions. Okay, so let's start with combinations. And I'm not going to stay long on combinations because they are, honestly, they're very kind of a basic topic. Combination of functions, it's more about the notation. So combination of functions, this is basic arithmetic of functions. So what we're really going to focus on is the notation of it. If I gave you two functions, let's do two basic functions. F of x equals 2x plus 1, and we'll say g of x equals, I don't know, 3x plus 4, okay? So we've got these two functions, f of x and g of x. If we want to do basic arithmetic with them, or if I'm going to ask you on the test to do basic arithmetic, I need you to understand the notation. So if I ask, let's say for A, to do f plus g of x, all I'm asking you to do, so this means f plus g of x, means we're going to add the two functions together. So all it means is f of x plus g of x, okay? So 2x plus 1 plus 3x plus 4. Add like terms. I'm going to assume we all know how to do this. You get 5x plus 5. Really basic stuff, okay? This is going to be one of those, oh, thank God he asked this question on the test. This is easy, okay? Don't make it harder than it has to be. Now, let's say I included a number. I'm going to mix it up, and let's say we had g minus f of 2, okay? Now, look, you can think of this question in this way. So this is just g of 2 minus f of 2. So with numbers, it's kind of nice. You can plug in the number and then subtract it, right? So g of 2, if I go back to the g function over here, g of 2, I'd plug 2 in. So 3 times 2, 6 plus 4 is 10. So g of 2 just winds up being 10. And then f of 2, well, I'll go over here. 2 times 2 is 4 plus 1 is 5. So 10 minus 5.
So why is the g minus f there?
Say again.
Why is the g subtracted by f there?
This is how it's notated. Like that's what the question's going to say. And it's how, yeah, it's how it's notated. So if I wanted to subtract functions, I would notate it that way. And we really do. You honestly, I say you, like this is something used quite frequently. Like if I wanted to find a revenue function, let's keep these two examples here. If I wanted to find a revenue function, you would multiply price times quantity sold. So sometimes those can be two functions. So you just multiply them together. So if I wanted to multiply these together, let's just, I'll keep it over here. You guys can go over here. You can see this. So let's say for C, if I wanted to multiply these together, it would look like this, FG of X. Okay, FG of X. That means multiply. So all we're going to do is multiply the two functions together. So 2x plus 1 times 3x plus 4. Okay, now for this one, we've got to FOIL it out and add like numbers, all that fun stuff. So 2x times 3x, that's 6x squared. 2x times 4, 8x plus 3x plus 4.
Is this simple math? Like this?
Yeah, it all got harder from here, right? This is just basic polynomial math. This is the polynomial section. If you guys took, and I know, I think all three of us that are here right now, we took Dev Math 1 and 2, or beginning or intermediate, however, whatever it's called then. And yeah, there was a nice section on this. Now, lastly, I'll tell you though, the division's the easiest one. So if I wanted to divide these, you would actually write it as a fraction. So you'd say like f over g of x, and you just write it 2x plus 1 over 3x plus 4.
You know, can I give it like is 2.6 the same as like 2.5 and 2.3? Because you gave us a lot of homework.
I don't know. We'll see when we get there. I don't remember, honestly. So with this question though, typically comes the domain. what's the domain of f over g of x? Okay. Nope. So let's look at this one. So we've got to say 3x. Nope. 3x, well, you're just guessing right now. They're good guesses, but they're wrong. 3x plus 4 can't equal 0. What do we need to do first? Booyah. So what were you missing? Negative. So divide. You got to subtract the 4 and then divide the 3. So look, x can't be negative 4/3. So therefore, again, we have to write it as an interval. So it can be anything else, right? So if you go back to that interval section that we talked about this, but negative infinity to negative 4/3 union negative 4/3 to infinity. There we go. Okay. I'm not going to stick too long on this one because we're going to get to compositions, which really kind of typically students struggle with the concept of compositions more. I want you to look at the homework and really it should be a review. This should be a review except the notation. Okay. Except the notation part. This is just a review, kind of a basic polynomial addition, subtraction, multiplication. Okay. So now let's get to one of my favorite lecture sections because we get to talk about, actually I get to hear your creative brains at work. Okay. So this is a composition. Now compositions are a little different. Now the way they're notated is with a little circle, and it looks kind of like a degree symbol, but it's in the middle. So it looks like this: f composed of g of x. Okay, so that it's a circle. It's not an O, and it's in the middle. It's not up top like a degree. It's in the middle. So f composed of g. Now, what this actually means is that the f function is composed of the g function. So what we're actually going to do for this one is actually plug the g function into the f function. So it's not multiplying, it's not dividing, it's nothing like that. Those are combinations. This is composition. So now another way to write this is f composed of g of x. So look, notice now the g function is inside the f function, and order matters tremendously for this one. Okay, order matters tremendously. Actually, it matters completely because that second function goes into the first. So if we reorder this one like g composed of f, the f would go into the g here. So this would be g composed of f. And I'll tell you, students don't typically get the math wrong. The math isn't that big of a deal. I mean, you'll see it does get a little tricky, but we've got to understand the order and putting something into something else. So I'm going to ask, I got 3 of you guys here right now. And if you, Amanda and Jane, if you want to type this in, that's fine. But I want you to think of something in the real world. Now, this won't, it doesn't have to work algebraically out. We haven't even got to the algebra yet. Okay. Something in the real world. When you take one thing and you put it into another thing and it becomes a whole new thing. And I'll give you a minute to type or just if you want to chime in, that's fine. There's no horrible examples, but I'll tell you if it's an example that works well with this composition or not. So you take one thing, plug it into another, you kind of like put it in, right? And then it becomes a whole new thing. Huh? No, that's fine. It's not the worst thing, but that's more of like a mixture, right? Which is not a bad example of what I'm asking for, or like sugar and tea, right? Making sweet tea, but yeah, sugar and tea is not a horrible example. I'm thinking more something. If you want to stay on the food route, these are always food examples are always good with this one. But with the sugar and the tea, it mixes together, so it's a little. It's like they don't kind of keep themselves in a way, right? But it's not a horrible, I've heard some doozies of examples for this. That's not the worst one. And actually, it's a good example. Can you guys think of two out there, Janie and Amanda? I'm sure people watching this video later are thinking of them and they're wishing they would have came to the lecture. My brain automatically went anatomical, but let's say, okay, yeah. Yeah, I've gotten that anatomy lesson a few times, or I should say like, what is it like? There was a class I took in college called the biology of sex, and it was nothing like, it actually was very, very hard class. But no, that's not a horrible example. That example is not bad, but just to keep it more, PG, I won't go there. But yeah, like ice cream and cones, not a bad example. Not a bad example, but I'm gonna use a different food example. That ice cream and cone's not bad, but it feels like kind of ice cream and cone, you stack it a little. Even though one does go into the other. That's not bad. I'm gonna go a different route. Because that's fine, Amanda. Trust me, that is okay. I'm gonna go with a jelly donut. Because I think it's a good food example. Okay? Jelly donut. And now I need you to think a little outside the box here, or I guess inside the box because of composition. But we're going to say J of X is our jelly donut. Or actually, I'm sorry, is our jelly. And D of X is our donut. Okay? And now if I wanted to make a jelly donut, and this is why I bring this up. If I want to make a jelly donut, I have to order this correctly. Okay? So if I wanted to make a jelly donut, is the jelly going to go to the left or is the donut? The donut, exactly. So it's going to be a donut composed of jelly. Okay? So donut composed of jelly. And the jelly goes into the donut. And this gives us a jelly donut. Now, if we went the other way, J composed of D, this would be donut jelly. And that sounds awesome. Yeah, in my brain, I think of it like chopped up donut inside of a jelly jar. But yeah, you're not wrong. I think I would eat that. I would eat anything. I'm not picky. But I would definitely eat donut jelly, especially if it was sold like at a farmer's market and they called it like some, support local, eat donut jelly. I would eat it. Okay. So, but look, the whole point of this kind of exercise is to realize, look, the order matters and whatever second goes into the first. So I'm going to get to the algebra here now. Okay. And I'm going to give you a real world example. You've probably trademarked it. Yeah. I should. And I've used this example for a while. I feel like there's precedence now. I should have domain control of donut jelly. So let me give you a real world example you've probably used before. You should have used if you're kind of budgeting stuff. Let's use a coupon at a store. So I'm gonna do one that's algebraic, but kind of a real world algebraic example. Let's say we go to a store and we're going to say X is original price. Original price for some item. Okay. What do you want to buy from the store? Something that you might use a coupon for. Whoever answers first. Huh? Janie, Amanda, we're going to the store. Cat food? Heck yes. Original price for cat food. So we're going to do two functions here. We're going to do a coupon function that we got in the mail that said if you buy, 80 pounds of cat food, you can get $10 off. But we'll say it's X minus 10. You got to buy the fancy cat food, and then you get $10 off if you buy, so many pounds of it. So that's our coupon function. And I labeled it, C of X for coupon. Now we're going to do the one, that's going to be there no matter what. Tax. Now the tax amount in home, the last time I checked, it was around like 9%. Hey, there's cat food. The last time I checked, the tax amount in home was like around 9.2%. I don't know what it is. For this example, we're going to call it 9.2%. And there's a quick way to get tax. So I'm not worried about coupon. So we're just looking at tax now. there's a quick way to get tax. You just multiply whatever the original amount is by 1.0 and then whatever the tax is. I think it's 92. It might be more now. So 1.092. So if we'll do the math here real fast. Mr. Franklin was telling me one thing about these laptops, they've got a calculator key. Boom. So let's say how much, Janie, help me out here. How much was that cat food? Which if it's more than less than $10, we'll have to make another number up.
Between 6.5% and 11.5%.
So we're right there. Yeah. How much is that cat food, Janie? What's your guess?
It's usually like $12, isn't it?
I have no idea. I've got dog food and my dog, it was cheap. Let's say $9. So if you take $9 and multiply it by 1.092, let them lock off. Yeah. 9 times 1.092, you'll get $9.83. So that's what you would pay with taxes. Okay. Yeah. My dog has allergies. Actually, it's my dog. It's my wife's dog first. And it has allergies and we have to buy like some sort of crazy expensive dog food that if I go to All Pet, I get all the punches every time I use it or buy it. Okay. But realize we've got two separate functions here, but when we go to the store with a coupon, if we want our total price, we're going to do one of these before the other one, right? So what they're going to do is they're going to take the coupon first, and then they're going to give us our total amount, our taxed amount after, okay? So if I go to All Pet or Walmart or wherever, and I want an equation for this cat food, and I know I get $10 off. So let's say I have to buy like the super bulk mega bag, right? I get $10 off. Well, then they're going to turn around and take tax. So if I want, let's say the composition here, I would want to put the coupon price into the tax price. So I'm going to write it as T composed of C, okay? Because I'm going to take the coupon and then I'm going to put it into the taxes. Now to do that, oh yeah, I haven't really talked much about this, have I? I haven't talked at all about it in this so far. To actually do this algebraically, to put C into T, you take whatever C of X is equal to, so that's X minus 10, and then you plug it into the X value for T. So you take the entire function for that second function and plug it into the X value for T. So this winds up being 1.092 times, now our X value is actually X minus 10, okay? Now I'm going to distribute this. I'll do more examples just to show you what's going on. I'll distribute it, get 1.092X minus, now 10 times that's going to be, what, you just moved the decimal, right? 10.92. Okay. So let's say we trot up to the Walmart or All Pet or whatever, and it turns out the original price for this cat food is a bulk cat food. We had to buy a lot of it. Was $80. Okay. It's $80. And I've got my coupon. I know what tax is, and I want to know how much am I going to wind up spending in the end. So I'd say 1.092 times 80 minus 10.92. So that winds up being, I'm going to use my calculator up here, 1.092 times 80 minus 10.92. 76.44. So we saved about $3.50, $3.56 if you want to be correct, because of tax, right? Remember tax. You're not going to get the full $10 off. Okay. Question. So that's a real world example and a nice kind of basic example before we get going. Okay. But the idea here is that you take whatever's in this second function and you plug it into the first function. Okay. Whatever's in the second function, you take it and you plug it into the first function. Okay. So let me give you another few examples because I've got to text my wife back. Again, my son's getting his braces put on this morning and I'm getting texts about stuff. So let's say I gave you f of x equals 2x plus 1. So this is just regular, boring, old functions. f of x equals 2x plus 1, and g of x equals 3x minus 4. Actually, I think if we do plus 4, it was like the example from before. So I'm going to ask you two different functions. I want you to find f composed of g, and I want you to find g composed of f. So try those real fast. F composed of g and g composed of f. And then I can.
I can't even believe that I used to wake up at 6 a.m. to go to school.
Isn't that crazy?
I can't even believe it. But I also didn't have the job that I had.
Where you working?
Baxter.
Oh, you told me that. Okay. So let's see here. So I'm going to take the g function for this first one. I'm going to take the g function. I'm going to plug it into the f function. So what that means is I'm going to take this entire equation and I'm going to plug it into that x value for the f. So I get 2 times 3x plus 4. A little bit, yeah. And the combinations. Distribute the 2, and I get 6x plus 8 plus 1. So I wind up with 6x plus 9. And then, so g composed of f goes backwards. So I'm going to take the f and I'm going to plug it into the g. So I'm going to take this entire f function and then plug it into that g function. So I get 3 times 2x plus 1 plus 4. So 6x plus 3.
If this is in the homework, if these types of questions are in the homework, what is the book gonna tell me? And like,
Oh yeah, I'll look at the homework here in a
how's the
second.
book
Gonna word it? Yeah. Give me a minute. So
It's just these questions.
it's gonna look really similar to this. So part C though, let's add a number in here, and this is what's a little different than the composition or the combinations. So for part C, if I ask you for, let's say f composed of g of 2, look, I've got f composed of x. I've got the equation already, so now I'm gonna plug 2 into that. So 6 times 2 plus 9. Okay, since I know f composed of g of x is this equation, well, now my x is 2. So I'm going to plug it into there. So I get 12 plus 9. So I get 21. So same thing like for part D here. If I did f or g composed of f of 2, I'm going to use this equation now. And I'm going to say 6 times 2 plus 7. So 12 plus 7. So I wind up with 19. Okay. So if you have a number, if they ask you for a number, find the equation first and then plug it in. That's the best way to do it. And yeah, Kayla, that's a good question. Like, how are they going to ask this in the book? Is it going to be different? And I think it asks it just like
Honestly, it seems like a lot of. It seems like math does that a lot, doesn't it? Like it does things where it's something very simple, but it's just like because.
I'm listening.
Because all that is just that's just 2x plus 1, and then like because I've seen these problems in like basic algebra too. There's 2x plus 1, and there's like, okay, what would the answer be if x was 2? That's all. That's what they ask.
Yeah.
Instead of that.
Yeah.
It's written different.
Yeah, it is written differently. I'm going to steal one straight from the book there for you. No, you're right. And it's all building on itself, right? So it shouldn't look foreign. because we're all building up to it, right? Like if I plopped you into this class and you hadn't seen algebra before, you would be thinking quite different than that. You got me. Let's steal one from the book. Let's say this is number.
I have a question about what we just did.
Oh, I'm sorry. Let me go back, Amanda. Ooh, okay.
Okay, on the previous example with the cat food thing.
Yes.
Okay, so when we come to the one we just did, I didn't realize we're supposed to split it up like that.
What do you mean by split it up?
Okay, so the 2 is outside and then you add the +1 on the inside. So this, I guess I just got confused.
A or B? Which one are you talking about? A or B?
Either.
Okay. Yeah. No. Okay. So let's just look at A real fast, and I'll go through it again. So if I've got f composed of g of x, look, the order matters, right? So g, this second function is going to go into the first function.
G is going inside that.
Yeah. So look, I'm going to box in my g function here, and then what you do is actually you take that entire box, and you're going to put that inside that x value. Okay.
Yep. I just confused myself when I was doing it.
Okay. Does that make sense now?
Yes, it does. I just confused myself.
And sometimes, and I understand, like whenever I'm putting these on paper, like you write them down, and it's like it takes a minute to just kind of get it. No, that makes complete sense, Amanda.
Okay, thank you.
Yeah, no problem. So okay, let's steal one straight from the homework. This is number 64. I'll do an even one since you don't have the answers in the back. So 64, we've got f of x equals 6 minus 3. And g of x, which equals x plus 3 over 6. And the question states, actually, the exact same thing I asked you. If you go to page 298, A, B, C, and D are exactly what I asked you for in that last example. So A asks for f composed of g of x. Okay, so let's do that first. So I'm going to take this g function, and I'm going to plug it into the f function, right? So this is my x value now. So 6 times x plus 3 over 6, right? Minus 3. This one's kind of neat. Hey, I've got other colors. I haven't used them yet, though. Let's see if it's bold. Look, check this out. If you've got a fraction and you're multiplying it by an integer, then these two cancel. If they're the same number, and they definitely are, boom, those cancel out. So that winds up being x plus 3 minus 3. Hey, 3 minus 3 is 0. So it winds up being x. Kind of cool. This is going to mean something in our next section, okay? When you take a composition and you wind up with x, it means we have an inverse, which we'll talk about. Stay tuned. We'll talk about that tomorrow, okay? But let's go the other way. So now let's do g composed of f of x. So I'm going to take the f, and I'm going to plug it into the g. I think this one will be a little easier. So this whole function turns into that x. So you wind up having 6x minus 3 plus 3, right? That's our x value. And then all over 6. Okay, negative 3 plus 3, that's 0. So we have 6x over x. Hey, these 6's cancel. And look, we're left with x. Okay, this happens. If you wind up having an invert or having an inverse, when you take the composition, the order doesn't matter. You'll wind up with x's. Okay, kind of neat. I know you don't have to tell me. Now, what's nice though is these just equal x. So part C asks, what's f composed of g of 2? Well, it's just 2. Okay, because f composed of g of x is just x. So you plug that 2 in, you get 2. Same thing for D. G composed of f. 2 is just 2. Okay? That's how they ask it.
Is it because it's only x? So if you
Yeah, if it was an equation, like x plus 5, you'd add 5 to it, right? Like if we go back to that last example. like back here, since we got f composed of g of an actual equation, when I plug 2 in, I just have to plug it in 6 times 2 plus 9, 21. So yeah. Yeah, it's just because it's just x. It's a very special example that's nice to hit in this section because we're going to see it a few times in 2.7. Okay. Oh, let's think out. Let's go backwards now. I know we might not totally grasp this concept yet, and that's fine. But let's go backwards now. What if I gave you a composition? And I want your brain to really think about this one. I'm going to give you f composed of g of x. So let's say 3x minus 1 squared. No, I do not. Yeah. Sometimes there's pins laying around. Okay. I'm going to give you this composition, 3x minus 1 squared, and I'm going to ask you for f of x and g of x. Okay? I'm going to ask you for f of x and g of x. Okay, so let's think about this. Remember, f composed of g, that means g goes into the f function, right? So I'm going to kind of notate this here. This means the g function is considered the inside function, and the f is considered the outside. Okay? And if I look at this example, the inside function's sitting right there. Do you guys see that? 3x minus 1. But and typically the inside's easier to see, okay? And then if I wanted to get 3x minus 1 squared, I've got to plug this into x squared, right? That would be my outside. Look, if I ask you to find f composed of g of these two functions, you would take this function and put it into x, and you would wind up with 3x minus 1 squared. Okay? So let's try another one. Get your brain thinking. I'm going to steal this one from the book. Let's say I've got f composed of g of x, and it's 1 over 4x plus 5. And again, I want the outside function. Remember, this is the outside function because it's to the left. And I want the inside function. Okay, I'm going to think of this as parentheses, right? This is a fraction. And the inside function is typically the easier to spot, the 4x plus, 4x plus 5. But if 4x plus 5 is the inside function, what would the outside have to be? Booyah. 1 over x. Okay? Now look, it's okay if you are going, oh my God.
Are you allowed to write 1 over x?
Yeah, 1 over x. Yeah. Oh, yeah, you are. Yeah. So I see where you're going with that. Look, it's okay if you're not quite grasping this yet before you actually do the homework. So once you're doing the homework, this is kind of towards the end because you've done a lot of examples of compositions. This gets easier to spot. Yeah. No, it's not hard. Okay. Questions? Okay, the last type of example is actually graphing. Oh, you have your book on it? Sweet. I want you to look at on page 298 because I don't want to draw this graph. Janie and Amanda, do you both have your book on the other side of that screen?
Yeah.
Okay, Janie, do you have your book? Are you there? It's a page. Okay, so page 288, I want us to look at number 91 through 94 because there's a graph involved with it. 91 through 94. And we'll do the odds, or the evens, I should say. So now look, the blue line is f of x and the red line is g of x, right? Oh, hey, look at this. I might have both of these. So the blue line is f of x and the red line is g of x. Look at that. Getting fancy with my markers. Okay. The question for 92 asks, what's f composed of g of 1? And I want to talk about this because I kind of skimmed over how to equationally do this if we don't have the equation. I know that sounds goofy, but look, it does not give us the equation for either one of these lines, right? Now, the way you think of this actually is you take the 1 and you plug it into the g. So it looks like this: f composed of g of 1. Okay? F composed of g of 1. And then we're going to work inside to out. Look at that graph for me. Look at that graph and tell me what g of 1 is, or what you think g of 1 is.
Wouldn't it be part of the red line?
It's the red line, right? Because it's a g function. So what's g of 1?
It doesn't go to 1, doesn't it? The positive 1 doesn't go there.
Now, what's the 1 mean? Remember, in function notation, if I gave you g of 1, what is 1? Is it the x or the y? It's the x, right? So if we look at our graph, at x equals 1, where is our g function?
It's on the negative side.
It's on the negative side. How negative?
It's -4, -4.
No, not -4. That one more, right? -5. Look, if you look at that graph, if you go to x equals 1, go to x equals 1 and go all the way down, you'll see it crosses at -5. 1, -5 is the coordinate on the g function. See the red line?
You're talking about the point where it gets to -5?
No. Look at the red line. No, look at the red line. We've got this red line. This is why I'm going over it.
Oh.
And at x equals -1.
For reference, I look at every single point as if it's like it's passing it on the actual axis of the graph, whatever you want to call it, an actual line. So when you say like, yeah, it gets to -5, I'm saying it actually touches -5. It's not.
It goes through -5. Is that what you're saying?
It doesn't touch it on the actual like bulb.
Oh, yeah, no. Don't worry about the axes. Because I'm asking you about x equals 1. The axes would be x equals 0. Because then we would go down to -4. Like, look, if we go to 1 here, you get it now? Okay, clicked. At x equals,
one down the front.
exactly, 1, 2, 3, 4, 5. You'll see the line goes through. Now, it does go through like a -4 on the axis. So it looks something like that.
Are we doing 91 or 92?
Its numbers are.
Oh, I'm sorry. I'm doing, hold on a second, Caleb. I'm doing 92.
Oh, okay.
Yeah, this is 92.
So you could say that its coordinates could be like 1, -5, 0, -4, -1, -3.
Exactly.
-2,
Exactly.
-2, -3, -1.
Yep.
0, -4.
Okay. Yeah, hold on. So now, but look, all we're worried about though for this example is 1. So at x equals 1, our g function's at -5. Good. Oh, no, I got you. So now though, we've got a whole new example. We got f of -5. So now we've got to go to the blue line here, right? So when x equals -5, what's the blue line? So we've got f of -5, right? So x equals -5, but what is the f value when x equals -5? +3. Okay, I'm going to ask you guys on the internet there, Amanda, Janie. Does that make sense? Or do you? Because there's not a lot of math involved. It's just kind of, it's just pulling it off the graph.
F represents the like y-axis.
F and G are just the y values. Right.
So
Yeah,
how
it's
did
just-
we get to 3?
Okay, now are you looking at the graph right now?
Yes.
Okay, so now all I'm asking you to find is f of -5. So if I go to x equals -5 now, 1, 2, 3, 4, 5. Oh, hold on 1 second.
Oh, I see.
Did you see it now?
Yeah, I see it now.
Okay. What were we saying, Caleb?
I feel like something to like it's probably like to probably incorrect, but like
No.
another good way to like say this is like, because first time you like talked about this like this sort of thing, I also got confused.
Okay.
You know how it's rise over run?
Yes.
I can't remember what type of equation it is.
Slope.
So
Mhm.
yeah, sure. This is kind of like this is run and then rise. You have the run, but you're trying to find the run.
Yeah, I guess in a way. That's more about change, though. This is stagnant movement or no movement. Yeah, I see where your brain's going there. Yeah, no. It's X and Y, right? X and Y. So X is run, right? And Y is rise. It's not, yeah, I like where your brain's going actually on that one. Okay, so I'm going to give you guys homework now
Can we do one more example?
of this one.
Yes.
Sure. I'm going to make one up because there's only like 4 questions. So I'm going to make one up for you, okay?
Okay.
They did G composed of F of 0. Let's do the opposite. Let's do F composed of G of 0. Okay? So this is just my made up one. Now, if I want to do F composed of G of 0, I've got to plug the 0 into G first. Okay? So I'm going to find G of 0. Okay, Amanda?
Mm-hmm.
If you look at G, it's the red line, right?
Yes.
So when X equals 0, what is G? What is Y equal? If it doesn't make sense, let me know and I'll go over it.
It's not making sense.
That's fine. Okay. I'm just going to focus on this G of 0. Now remember, this is our G line, right? On the graph.
Mm-hmm.
So this is our X value. So our X axis is 0 is right there, right?
Yes.
So I'm going to go down and I see that it crosses right there at -4. So when X equals 0, Y equals -4. Does that make sense?
Yes, it does.
Great. That's my Y value. Okay. So now we're kind of starting back over now. We're saying, well, what's F of -4? And now for this one, though, we're going to look at the blue line, right?
Mm-hmm.
So if I go now, but here's my X value still, because X values are always on the inside. Okay. This is my X value again. So I'm going to go over 1, 2, 3, 4. This is my 4 digit. So -4. But now my F line's up here.
Yeah.
So what do you get for F of -4?
2.
Boom, shakalaka. You're getting it.
Okay, good.
Okay. I know, and it might not be solidified yet, but here, look, this is like kind of at the very end of the homework. So when you're working through it and you get there, it might come across a little easier now that once you've done all the homework. Does that make sense?
Yes.
Okay. And if not, let me know. I like this example. It might show up on a test. So I would know it. Hint, 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 hint. Okay. Oh, for homework. Yeah, I guess. So for homework actually starts on page 297. And remember, the first questions are about domain. I'm going to ask you a few of those, actually, just a few. So 3, 7. Yeah, sure, 3 and 7. And then we're going to start on the combinations, which I want you to do 31. You don't have to do all those. So for 31 through 57, do every other odd. And once you understand the concept, you can kind of go on. Okay? Not a big deal. So 31 through 57, not 57, through 50. Do every other odd. Then we get to combinations or compositions. So 50 through 65, I want you to do all those. Typically, students struggle more with that stuff. And then 75 through 93, odd. Okay? So that's our homework there. Okay? Question?
I just noticed something.
What's up?
On the examples we just did, you put page 288,
Oh, it's 298. Yeah. I'm sorry.
just so people don't get confused later.
They are totally going to get confused because if they are watching this now later, yeah, they're going to get confused. That's fine. Thank you for noticing that, Amanda. It's definitely 298. And if I knew how to edit, I would go back and change it. But I don't. They don't pay me enough for that. Okay. Do you guys have any questions, Amanda and Janie?
No, I'm good.
Janie, you good? Great. Okay. I will see you all tomorrow. Oh, I'm a little confused. Well, you can stick around, Janie, and you can ask me. That's fine. I'll see you. Let me stop this YouTube stream here so